All right, lesson 4.3 is inelastic collisions and explosions. So things coming together, or then we're gonna look at things exploding apart. It's all about conservation of momentum. Okay, so the directions will say draw the situation before the impulse and then draw the situation after the impulse and then show your workout. Okay, so here's the situation before the impulse is two cars are coming at each other. And realize if it's going left, we do need to say that's got a negative velocity. So this one's going at 4 meters per second, 3 meters per, negative 3 meters per second. This one's 10 kilograms, 15 kilograms. What we're going to say is the momentum, I'll just say P before the collision, before the impulse, equals the P after impulse. Impulse, remember, is a force times a time. Okay, so it's like some change in motion is an impulse. So in this case, collision. Okay, so after, this is the before. Let's draw the after, what we know about the after. We're saying they're going to stick together. Okay, the directions will say that, you know, that they stick together. They're coupled together, so these train cars get hooked together. The masses won't change. And then we want to know, what is it going to do afterwards? They're going to come together, get stuck together, and then they're going to move together, and what's going to happen? You know, just by inspection, I do know that it's going to go to the left, but even if you didn't know that, we could figure it. We're going to figure it out here with the equation. Okay. So let's write the equation. The P before equals the P after. P before, remember P, momentum, 10 times 4. We're doing the whole system. So we're going to do both cars. So we're going to say plus this momentum, -3. Okay, that's the momentum, the total system momentum before the collision. Then afterwards, we've got the 10 kilogram going with velocity V, right? And we've also got the 15 kilogram going with velocity V. Okay, because they're coupled together, these two variables are the same. And it's just a matter of some algebra. This is 40 kilogram meters per second plus negative 45. So really, if I figure this all out, I'm looking at -5 kilogram meter per second. And then over here, I've got 10V plus 15V is 25V, right? 25 kilograms times V. Okay, divide each side by 25 kilograms. V equals, what, 1/5 or 0.2. The kilograms cancel, right? Boom, boom, meters per second. Okay, so these are going to be moving together at 0.2 meters per second, which is actually to the right. Negative, sorry. Right, negative 0.2 means they're moving to the left together at 0.2. Okay, which makes sense because their momentums are almost the same, so they almost canceled out, came to a stop, but they're going to move a little bit to the left because you had more momentum here than what you had here. Okay, and then the other type of problem you'll see is where they're going to explode apart. Two cars move together. Let me give you the masses. Let's say it's saying 10 or 15 kilograms here, 10 kilograms here, and they're moving together at 4 meters per second. So this is the before impulse situation. Okay, after, there's an explosion that separates the cars, sends the front car forward at 6. Okay, so there's this explosion, this impulse that happens. This one goes forward at 6 now. Still in the same mass. And then the question is, what's going to happen to this car? Okay, and I actually don't know if it's going to go right or left. I kind of assume it's going to go left. Well, it's moving pretty fast to begin with. I don't know. Honestly, I would say probably it's going to go right, but we basically got to figure it out to see. Okay, so the P before equals the P after. The total momentum before the equals up here equals the total momentum after down here. So before we got 15 kilograms times 4 plus the 10 kilograms times 4. Okay, they're both going right, so that's positive velocity. After, we've got the 10 kilograms times 6 plus the 15 kilograms times V. So it's just a matter of setting it all up. You know, the total before equals the total after. If velocities are to the left, make sure you put in negatives. But if they're to the right, we're going to just put in positives. Okay, and solve her out. What do we got here? What's this? 60 plus 40, is that right? 60 plus 40, 100, I think. 15 times 4, 60, yep. Equals, this is going to be 60 kilogram meters per second plus 15 kilograms times V. It's just an algebra equation. We can minus 60 on each side. So we got 40 equals 15 V. Okay, so divide by 15 is the last step. I feel like I screwed something up because my units are all going to cancel here. Doesn't make sense. What did I do? These kilogram meter per second. 40. Oh, this is just kilograms here. My bad. So we divide each side by 15 kilograms. So just the kilograms cancels. So 40 over 15, what's that? 2.2 and 2/3, I believe. 2.67 or 2.7, I'll say, meters per second equals V. Okay, so what that means is it's actually going to the right. Because it came out positive, if it would have been negative, it would have been to the left. So these are actually going, this car will basically slow down. It's kind of, they're both moving along at 4. The explosion happens, this front one shoots out at 6, and this one will keep going forward, but it's going to go slower, if you can imagine that. So it kind of is that scenario where this one gets shot out, but this one slows down because of the impulse. Okay. Give you 2 days on this next assignment because it is kind of long, but you do need to draw everything out. But it's not actually due. You got 2 days to work on it. Okay, have a good day, guys.